Hello friends, I Anjali Shinde, Associate Professor, Department of Mathematics, S.V.K.T College, Devali Camp, Nasik. In the previous lecture of FY/BSc Calculus, we have studied what is meant by exact differential equation and the necessary and sufficient condition for the differential equation m dx plus n dy equal to 0 to be exact. We know that the necessary and sufficient condition for the equation m dx plus n dy equal to 0 to be exact is delta m by delta y equal to delta n by delta x. Today we are going to see what is meant by integrating factor. If the equation m dx plus n dy equal to 0 is not exact differential equation, it can be reduced to exact differential equation by multiplying it by some function of xy, say f of xy. Then this multiplying the equation by this f of xy, the equation becomes exact. This function f of xy is known as integrating factor. So, if m dx plus n dy equal to 0 is not exact, then we multiply this equation by some function of xy and then this equation becomes exact differential equation. This factor is known as integrating factor. Today we are going to see some rules to find the integrating factor. The first rule to find the integrating factor is if mx plus ny is not equal to 0 and the equation is homogeneous, means m and n are homogeneous. Homogeneous means they are of same degree. Then in such case 1 upon mx plus ny will be the integrating factor of the equation m dx plus n dy equal to 0. So, this is first rule to find the integrating factor. For example, suppose we want to solve the differential equation x square y minus 2x y square dx minus x cube minus 3x square y dy equal to 0. Now compare this equation with m dx plus n dy equal to 0. If you compare this with m dx plus n dy equal to 0, m has the value x square y minus 2xy square and n has the value minus x cube minus plus 3x square y. Now see what is delta m by delta y. Delta m by delta y, that is, we are differentiating with respect to y, treating x constant, and therefore this becomes x square as it is constant, derivative of y is 1 minus we are treating x constant, so 2x, derivative of y square, that is 2y. So it becomes x square minus 4xy. Now see what is delta n by delta x. Differentiate with respect to x, treating y constant, derivative of x cube minus 3x square plus 3y constant, derivative of x square, it is 2x. So it becomes minus 3x square plus 6xy. Observe that dabba m by dabba y is not equal to dabba n by dabba x, and therefore the equation is not exact. The equation is not exact. Now, if you observe the factor mx plus ny, then observe that mx plus ny becomes x square y minus 2xy square into x plus minus x cube plus 3x square y into y. This is nothing but x cube y minus 2x square y square minus x cube y plus 3x square y square. X cube y gets cancelled and it becomes x square y square. This is not equal to 0. So, mx plus ny is not equal to 0 and this equation is homogeneous. Observe that every term has degree 3. X square y degree will be 3, xy square degree is 3, x cube has degree 3 and x square y has degree 3. Each term has degree 3 means that this is homogeneous of degree 3. So both the conditions are satisfied, that is mx plus ny is also not equal to 0 and the equation is also homogeneous, and therefore the integrating factor is nothing but 1 upon mx plus ny, that is 1 upon x square y square will be the integrating factor. Integrating factor means we multiply the given equation by integrating factor. So if you multiply the equation by integrating factor, we get 1 upon x square y square into bracket x square y minus 2xy square dx minus x cube minus 3x square y dy equal to 0. If you multiply to 0, it becomes 0. So we are multiplying by 1 upon x square y square, and therefore to both sides this becomes 0. So this implies us, it reduces to x square y upon x square y square. So it remains 1 upon y minus 2xy square upon x square y square. It remains 2 upon x dx minus x cube upon x square y square. So it remains x upon y square minus 3x square y upon x square y square. It remains 3 upon y dy equal to 0. Now observe that this is m 1 upon y minus 2 upon x, and this is n minus into bracket x upon y square minus 3 upon y. If you observe, see what is dabba m by dabba y. Dabba m by dabba y, you are differentiating with respect to y. So derivative of 1 upon y, that is minus 1 upon y square. And if you consider dabba n by dabba x treating y constant, so it is also minus 1 upon y square. Now observe that dabba m by dabba y is equal to dabba n by dabba x, means that this equation is now exact differential equation, and because this equation is exact implies that we are able to integrate, and therefore our rule is nothing but the solution is integral m dx over y constant plus integral terms in n independent of x dy equal to c. This is the solution. So the solution becomes integral m dx. M is this, so 1 upon y minus 2 upon x dx over y constant plus terms in n independent of x. The term which do not contain x is the second term. This minus minus become plus. So plus 3 upon y dy is equal to c. This term contains x. We don't want the terms containing x. So only this term remains and we are going to integrate this. Because y is constant, this becomes 1 upon y integral dx minus 2 integral dx upon x plus 3 integral dy upon y is equal to c. That is 1 upon y into x minus 2 ln x plus 3 ln y is equal to c, or we get x upon y minus ln x square plus ln y cube is equal to c, or we can write this as x upon y plus ln of y cube upon x square is equal to c. This is the solution of the given differential equation. So we have seen first rule that if mx plus ny is not 0 and the given equation is homogeneous, then 1 upon mx plus ny is integrating factor, means multiplying by that factor the equation becomes exact and the solution is given by our standard rule integral m dx over y constant plus terms in an independent of x dy equal to c. Now we will consider the second rule. Rule 2 says that if mx minus ny is not equal to 0 and if the given equation has the form some function of xy into y dx plus some function of xy into x dy equal to 0, then 1 upon mx minus ny is integrating factor of the differential equation m dx plus n dy equal to 0. So if the given equation has this form, that is y into some function of xy dx plus x into some function of xy dy equal to 0, and if mx minus ny is not equal to 0, then 1 upon mx minus ny is integrating factor of the equation m dx plus n dy equal to 0. For example, solve the differential equation y into bracket xy minus 2x square y square dx plus xy minus x square y square dy equal to 0. Compare this equation with m dx plus n dy equal to 0. So m becomes y into bracket xy minus 2x square y square and n becomes x into bracket xy minus x square y square, that is xy square minus 2x square y cube. So what is dabba m by dabba y? Differentiate with respect to y keeping x constant. So x is constant, derivative of y square is 2y minus 2x square constant, derivative of y cube is 3y square. So it becomes 2xy minus 6x square y square. Now n becomes x square y minus x cube y square. So what is dabba n by dabba x? That is differentiate with respect to x keeping y constant. Derivative of x square is 2x, y square constant, derivative of x cube is 3x square. So dabba n by dabba x becomes 2xy minus 3x square y square. Observe that dabba m by dabba y is not equal to dabba n by dabba x. And therefore, dabba m by dabba y is not equal to dabba n by dabba x, means that the equation is not exact. If it is not exact, it can be made exact by multiplying it by some function of xy, that is integrating factor. Now see, this equation has the form y into some function of xy dx plus x into some function of xy dy equal to 0. And whenever it has this form, we will search what is mx minus ny. If it is not equal to 0, then we have the integrating factor 1 upon mx minus ny. So consider what is mx minus ny. It is nothing but 2xy square minus 2x square y cube into x minus ny is nothing but x square y minus x cube y square into y. This becomes x square y square minus 2x cube y cube minus x square y square plus x cube y cube. X square y square gets cancelled and it becomes minus x cube y cube. So mx minus ny is minus x cube y cube, that is not equal to 0. Because the equation has this form y into some function of xy dx plus x into some function of xy dy is 0, and mx minus ny is also not equal to 0. This implies that the integrating factor is 1 upon mx minus ny, that is 1 upon minus x cube y cube. This is the integrating factor. Once we get integrating factor, we multiply the given equation by this integrating factor. So, multiply by minus 1 upon x cube y cube. Therefore, minus 1 upon x cube y cube into bracket xy square minus 2x square y cube dx plus x square y minus x cube y square dy is equal to 0. This implies minus x square upon y, we multiply with this, so it remains y upon x square plus 2 upon x dx. xy square upon x cube y cube with minus sign. So y square gets cancelled. Sorry, it is xy square upon x cube y cube. So it becomes 1 upon x square y plus, we are multiplying with this, becomes minus minus plus 2 upon x y cube gets cancelled plus, in bracket, when you multiply with this, it becomes minus x square upon x cube. So it remains 1 upon xy square minus minus become plus, x cube gets cancelled and y square upon y cube 1 upon y dy is equal to 0. So this implies m dx, this value is m and this is n. Observe what is dabba m by dabba y. Differentiate with respect to y, treating x constant. So minus 1 upon x square as it is, derivative of 1 upon y is minus 1 upon y square. So it becomes 1 upon x square y square. This is dabba m by dabba y. See what is dabba n by dabba x. Dabba n by dabba x becomes minus 1 upon y square constant, derivative of 1 upon x is minus 1 upon x square. So it is also equal to 1 upon x square y square. Observe that dabba m by dabba y is equal to dabba n by dabba x, implies that now the equation becomes exact. So this equation now it becomes exact. And if it is exact, then what is our rule for the solution? The solution becomes integral m dx over y constant plus integral terms in n independent of x dy equal to c. So integral m dx, m becomes minus 1 upon x square y plus 2 upon x dx over y constant plus terms in n independent of x. This term contains x, so we neglect this term. Only this term remains, that is 1 upon y dy is equal to c. Integrate y constant. So what is solution for this? Because y is constant, we take minus 1 upon y outside, integral dx upon x square plus integral 2 times integral dx upon x plus integral dy upon y is equal to c. That is minus 1 upon y integral x raised to minus 2 dx plus 2 integral dx upon x plus integral dy upon y is equal to c. And this is nothing but minus 1 upon y integration of x raised to minus 2, that is x raised to minus 1 upon minus 1 plus 2 ln of mod x plus ln of y is equal to c. That is minus minus become plus, it is 1 upon xy plus ln of x square y is equal to c. So this is the solution of given differential equation. So the given differential equation has this form: y into some function of xy dx plus x into some function of xy dy equal to 0, and mx minus ny is also not equal to 0. So the integrating factor is 1 upon mx minus ny. Once you multiply by that integrating factor, that equation becomes exact differential equation and you are able to find the solution of that differential equation. Now consider the next rule, rule 3. Rule 3 states that if 1 upon n dabba m by dabba y minus dabba n by dabba x is a function of x alone, say fx, 1 upon n in bracket dabba m by dabba y minus dabba n by dabba x is a function of x alone. It may be constant, because constant, every constant can be expressed as function of x also. So if this is constant, then integrating factor is e raised to integral fx dx. So this is the integrating factor in this case. If 1 upon n dabba m by dabba y minus dabba n by dabba x is function of x alone or constant, say fx, then the integrating factor of the differential equation m dx plus n dy equal to 0 becomes e raised to integral fx dx. For example, suppose we want to solve the differential equation y dx minus x dy equal to 0. So compare this equation with m dx plus n dy equal to 0. M becomes y, n is equal to minus x. So dabba m by dabba y is equal to 1 and dabba n by dabba x is equal to minus 1. That is, dabba m by dabba y is not equal to dabba n by dabba x, implies that this equation is not exact. If it is not exact, it can be made exact by multiplying it by some function of xy, that is integrating factor. But you observe that this is homogeneous because both m and n are homogeneous of degree 1. But when it is homogeneous of degree 1, we firstly try what is value of mx plus ny. If you observe that mx plus ny, here it becomes xy minus xy and it becomes 0. So the first rule cannot be applicable because one of the condition gets satisfied, that is m and n are homogeneous, but mx plus ny is not equal to 0. So rule 1 cannot be applicable. So we go to next rule. The second rule that we have studied, it if it is of the form y dx plus some function into x dy equal to 0, then 1 upon mx minus ny is also integrating factor, but that integrating factor should be simplest form. We will consider this rule. Suppose if 1 upon n into dabba m by dabba y minus dabba n by dabba x. Observe that this is nothing but 1 upon n, that is minus x, into dabba m by dabba y is 1 minus dabba n by dabba x is minus 1. That is nothing but minus 2 upon x, which is function of x only. We say this is fx. So 1 upon n, that is 1 upon minus x, dabba m by dabba y minus dabba n by dabba x, it is function of x alone, and therefore we are able to use this rule. What is the integrating factor in this case? The integrating factor in this case is e raised to integral fx dx. That is nothing but e raised to integral minus 2 upon x dx. That is e raised to minus 2 ln of x. That is e raised to ln of x raised to minus 2, that is 1 upon x square. X raised to minus 2, that is 1 upon x square. So 1 upon x square is integrating factor. That is, if you multiply it by 1 upon x square, so multiply the equation by integrating factor, that is 1 upon x square. If you multiply it by integrating factor 1 upon x square, the given equation becomes 1 upon x square into bracket y dx minus x dy equal to 0. Simplifying, we get y upon x square dx minus 1 upon x dy equal to 0. If you compare with this m dx plus n dy, m becomes y upon x square and n become minus 1 upon x, so that dabba m by dabba y, that is differentiate with respect to y, treating x constant, so it is 1 upon x square, and dabba n by dabba x, derivative of 1 upon x is minus 1 upon x square, so minus minus become plus 1 upon x square. Observe that dabba m by dabba y is same as dabba n by dabba x, means that now this equation becomes exact differential equation. And once the equation is exact differential equation, what is its solution? Solution is integral m dx over y constant plus terms in n independent of x dy is equal to c. Therefore, the solution is integral m dx. M is y upon x square dx over y constant plus terms in n independent of x. Now, observe that n itself contains x. So, there is no term here because every term in n contains x. So, is equal to c. y is constant, so it is y integral x raised to minus 2 dx is equal to c. That is y into x raised to minus 1 upon minus 1 is equal to c, or you can say that minus y upon x is equal to c. So this is the solution of the differential equation, that is minus y upon x is equal to c. So observe, we have studied third rule. If 1 upon n dabba m by dabba y minus dabba n by dabba x, it is function of x alone or constant, then integrating factor is always e raised to integral fx dx. Now we will consider fourth rule. So see, what is the fourth rule? The rule says that if 1 upon m dabba n by dabba x minus dabba m by dabba y is a function of y alone or constant, then the integrating factor is e raised to integral fy dy for the differential equation m dx plus n dy equal to 0. So this is the fourth rule. If we get 1 upon m dabba n by dabba x minus dabba m by dabba y as a function of y alone, then the integrating factor is always e raised to integral fy dy. We will consider the same example. Suppose we want to solve the differential equation y dx minus x dy equal to 0. Observe that comparing with m dx plus n dy equal to 0, m is y and n is minus x, so that dabba m by dabba y is 1, but dabba n by dabba x is minus 1. Because dabba m by dabba y is not equal to dabba n by dabba x, one value is 1, another is minus 1. So they are not equal, means that this equation is not exact. We have solved the same example by last rule, that is rule 3. Now check for rule 4. Suppose I will consider 1 upon m into bracket dabba n by dabba x minus dabba m by dabba y. It is nothing but 1 upon m. M is nothing but y into bracket dabba n by dabba x, that is minus 1, minus dabba m by dabba y is 1. So it becomes minus 2 upon y, and which is only function of y. Because this is only function of y, this implies that e raised to integral fy dy, that is e raised to integral minus 2 upon y dy is the integrating factor. This is nothing but e raised to minus 2 ln y, or it is nothing but y raised to minus 2 or 1 upon y square. So integrating factor now becomes 1 upon y square. Once we get integrating factor, we multiply the given equation by integrating factor. So multiply the given equation by 1 upon y square. So we get 1 upon y square into bracket y dx minus x dy is equal to 0. That we get 1 upon y dx minus x upon y square dy equal to 0. If you compare this equation with m dx plus n dy equal to 0, we get m is equal to 1 upon y and n is equal to minus x upon y square, so that dabba m by dabba y becomes minus 1 upon y square and dabba n by dabba x becomes minus 1 upon y square. Now observe that here both values dabba m by dabba y is same as dabba n by dabba x, implies that this equation becomes exact differential equation. And if it is exact differential equation, its solution is given by integral m dx over y constant plus integral terms in n independent of x dy is equal to c. Therefore, integral m dx, m is nothing but 1 upon y dx over y constant, terms in n independent of x. There is no term which is independent of x, and therefore here there will be no term. Y is constant, so 1 upon y is outside. Integral dx is equal to c. Integral dx is x, so it becomes x upon y is equal to c. So observe that this is the solution of the given differential equation. So x upon y is equal to c is the solution of this differential equation y dx minus x dy equal to 0. So we have seen 4 rules to find the integrating factor. Integrating factor means if the given equation is not exact differential equation, it can be reduced to exact differential equation by multiplying the given equation by some function of xy, say f of xy. That term f of xy is known as integrating factor, and the 4 rule to find the integrating factor. In the next lecture, we will see more examples to find integrating factor. Thank you.